Hi, I'm Mia, and welcome to Soft Physics. This channel is for anyone who has ever looked at the world and wondered what is really happening beneath the surface. Physics is often presented as something difficult, distant, or full of rules, but it can also be gentle, visual, and surprisingly beautiful. Soft physics is about finding that side of science. We take one idea at a time, slow it down, and look at it clearly until the hidden patterns of reality begin to make sense. Let's look a little closer, and welcome to Soft Physics. The heat in this coffee may once have come from a star. That sounds too big for something so ordinary. A cup on a desk, a little steam, warmth against your fingers. But the heat you feel here did not begin here. The cup is not the start of the story. It is just the place where the story has become touchable. Before this warmth reached your hand, the same energy may have been sunlight, electricity, pressure, motion, fuel, or invisible radiation. It may have crossed empty space as light. It may have moved through wires. It may have turned inside a machine. It may have been stored in matter for years or for millions of years before finally becoming warmth in water. So today, let's not ask the small question first. Let's not begin with, what is heat? Let's follow it instead. Let's follow the warmth in the cup and see where it leads. At first, the obvious answer is simple. The kettle made the coffee hot. But that answer hides the most important part. The kettle did not create heat from nothing. It translated energy, electrical energy, entered the kettle. The element warmed. Energy passed into the water. And inside that water, at a scale too small to see, molecules began moving, rotating, vibrating, colliding, and exchanging energy more intensely. That is the first quiet shift. Heat is not a substance poured into the cup. It is not an invisible liquid called warmth. It is energy moving through matter. More exactly, it is energy being transferred, because one thing is at a different temperature from another. Temperature tells us something about the average microscopic energy inside a material. Heat is the energy moving between things. A spark can have an extremely high temperature, but very little total energy. A warm bath has a much lower temperature, but it can transfer far more energy into your body. So, hot is not just one simple thing. It depends on energy, amount of matter, contact, movement, and time. Now think about the coffee cooling down. 10 minutes pass, the drink is still there, the cup is still there. Nothing obvious has disappeared, and yet something real has changed. The coffee can no longer warm your hand in the same way. So what did it lose? Not a visible substance, not much mass, not a magical ingredient called heat. What it lost was concentration. Energy that was gathered in the coffee has spread into the mug, into the table, into the air, into your hand, and out into the room. Cooling is not disappearance. Cooling is spreading. And even the way you feel, that spreading is stranger than it seems. Your skin is not a perfect thermometer. It does not simply report the temperature of whatever you touch. What it notices most strongly is energy moving into you or out of you. That is why metal can feel colder than wood, even when both have been sitting in the same room. They may be the same temperature, but metal pulls energy from your skin faster, so your body reports cold, not because the metal contains cold, but because your warmth is leaving you more quickly. The same thing happens with air and water. Air at 22 degrees can feel comfortable. Water at 22 degrees can feel cold. Same temperature, completely different feeling. Water carries energy away from your skin far more effectively than air does. So the body does not experience temperature alone. It experiences exchange. Touch is not passive. Touch is a negotiation between you and the world. But heat does not only reveal itself through touch. Sometimes you see its effects without realizing what you are seeing. Look above a flame, a hot road, or a radiator, and the background seems to wobble. The air shimmers. Distant objects bend and swim. A mirage appears like water on the road. You are not seeing heat directly. You are seeing light being bent by air at different temperatures. Hot air and cooler air have different densities. Light passing through them changes direction slightly, so heat can distort the path of light itself. It can make the world behind it appear to ripple. That is one way heat becomes visible. But there is another, stranger way. Your coffee is glowing. Your hand is glowing. The walls are glowing. The desk, the cup, the floor, the room around you, even objects that look completely dark in ordinary light, are giving off radiation. Most of it is not light your eyes can see. It is infrared. Infrared means beyond the red end of visible light. Just past the last color your eyes can detect, there is more light, invisible to you, but still real. A dark room is not truly dark to a thermal camera. It is full of quiet radiation from warm matter. In 1800, William Herschel did something beautifully simple. He split sunlight with a prism and placed thermometers in the different colors. The blue region warmed the thermometer less. The red region warmed it more. But then he moved a thermometer just beyond the red into a place where there was no visible color at all. And the temperature rose even higher. Warmth appeared where the eye saw nothing. The rainbow had continued past human vision. That discovery changed the meaning of light. It showed that visibility is not the boundary of reality. There are forms of light our eyes simply do not receive, and one of those forms carries the warmth we now call infrared radiation. This is also why color and heat are connected, but not in the simple way we might first imagine. A red painted object is not automatically hotter than a blue painted object. That kind of color depends on which wavelengths of light the surface reflects into your eye. But when an object becomes hot enough to glow from its own heat, the color of that glow can reveal its temperature. A piece of metal may glow dull red, then orange, then yellow-white as it gets hotter. Stars do something similar. Their color carries information about their surface temperature. So color is not just decoration. Sometimes it is a thermal clue. A thermal camera takes this further. It does not see heat directly, as if heat itself were colored smoke. It detects infrared light from objects and translates that invisible radiation into colors your eyes can understand. That is why a thermal image can show a handprint fading from a wall, a body in darkness, warmth leaking from a building, or clouds in planets radiating energy into space. It is not showing magic, it is showing energy leaving things. And that brings us to space, where heat becomes even less intuitive. People often say space is freezing, and in one sense, that is true. Space is unimaginably cold if you are in shadow, with almost nothing around you to share energy. But step into direct sunlight in space, and you can overheat. There is almost no air to carry heat away, by touch or by convection. No breeze, no ordinary cooling, just radiation. The sun warms Earth across empty space because heat can travel as light, not by touching the air between here and the sun, because there is almost no air between here in the sun. It travels as electromagnetic radiation. It crosses the vacuum, arrives at matter, and becomes warmth. So heat is not trapped inside contact. Sometimes it moves by collision, sometimes by flowing air or water, sometimes by invisible light across emptiness, and sometimes heat appears from something that seems completely different. Motion. Rub your hands together and they warm. Brake a bicycle and the brake. Compress air quickly and it warms. A meteor entering the atmosphere becomes bright and hot. A machine working hard grows warm. In each case, visible motion does not simply vanish, but heats up. It is changing scale. James Joule showed this with a beautifully physical experiment. Falling weights turned paddles inside water, and the water warmed. The motion of the weights became motion in the water's molecules. The energy had not disappeared. It had lost its obvious shape. Visible movement became microscopic movement. This is one of the deepest ways to understand heat. Heat is often motion after it has become too small and too scattered to see. Then comes the reverse question. If motion can become heat, can heat become motion again? Yes, but not perfectly. That question shaped the age of engines. Heat could boil water, make steam, push pistons, turn wheels, move trains, drive machines. But Sadi Carnot saw the deeper rule hiding inside all of that. Heat can do useful work only when it moves between a hotter place and a colder place. You need a difference, a contrast, a fall. And even in the best possible case, not all the heat can become useful motion. Some of it must spread away. That is not a small engineering problem. It is a limit built into reality. Heat is not just warmth. Heat is also the form energy often takes when usefulness begins to slip out of our hands. This may be the most important shift in the whole story. Energy is conserved, but usefulness is not. The universe does not lose the energy, but we can lose the arrangement that made the energy easy to use. Think of a drop of ink spreading through a glass of water. The ink has not disappeared. Every bit of it is still there. But once it has spread everywhere, the original drop is almost impossible to recover. What has been lost is not the material. What has been lost is the special arrangement. Heat is often like that. The energy is still in the room. That is the strange part. The room has the energy from your coffee. The air has some of it. The cup has some of it. The table has some of it. But the room will not politely gather all those tiny motions back together and return them to your drink. The coffee cools easily because there are many ways for its energy to spread out. But there are unimaginably fewer ways for all that scattered energy to organize itself back into one warm cup. That is the doorway into entropy. Not simply mess, not just disorder in the everyday sense. Entropy is about how many hidden arrangements can produce the same visible situation. Energy spread through a room can happen in vastly more ways than energy neatly concentrated in one cup. So heat seems to move one way, not because every tiny reverse motion is forbidden, but because gathering is overwhelmingly unlikely compared with spreading. And then, just when heat seems like a familiar story, it opens another strange door. Under the right conditions, sound moving through water can create light. This is called sonoluminescence. A powerful sound wave passes through a liquid and drives tiny bubbles to expand and collapse. During that collapse, energy becomes concentrated into an incredibly small region for an incredibly short time. and the bubble flashes. Sound becomes light. The exact details are still a subject of research, but the event itself is real and astonishing. It shows again that energy does not belong to only one form. Motion, pressure, heat, and light can transform into one another in ways that feel almost impossible until the experiment forces us to accept them. And heat also helped open one of the deepest doors in modern physics. Scientists wanted to understand how warm objects glow. Not just that they glow, but why they emit exactly the pattern of light they do. The old ideas did not work. Max Planck found a way forward by treating energy as if it came in small packets. A problem about heat and light helped physics step into the quantum world. So now return to the coffee. At first, it was just a warm drink, but now it is harder to see it as simple. Its warmth may once have been light from a star. It may have moved through wires, fuel, pressure, radiation, or motion. It became a microscopic movement inside water. It passed into ceramic, skin, air, table, and invisible light. It shimmered in the air. It glowed beyond vision. It spread into the room. And as it cools, the energy is not gone. It is simply less gathered, less private, less available to you as warmth in a cup. The coffee is ordinary only because we are used to it. It is not where the story begins. It is where the journey becomes touchable. If this helped you see the world a little differently, there's more to explore. Soft physics is about slowing down the big ideas behind reality and making them feel clear, visual, and quietly beautiful. Take a look at our other videos. And if this idea made you think of a question, let us know in the comments. We'd love to hear your thoughts. And if there's a topic you'd like us to cover, tell us there too. You can also subscribe to Soft Physics for new calm science explanations. And follow us on social media for extra clips, ideas, and behind-the-scenes updates. Thank you for watching Soft Physics. I look forward to discovering more with you in the next video.